Hello everyone, welcome to my workshop series, Empowering Faculty with AI for Scholarship and Teaching. This is the second workshop in the series. Today, we'll explore effective communication with large language models. While I will use ChatGPT and the OpenAI API for demonstration in this workshop, it is important to remember that there are other powerful large language models available, such as Google's Gemini, Anthropic's Cloud, Meta's Llama, and so on. Exploring multiple large language models can provide a broader perspective on the unique strengths and applications each model offers. Let's start by taking a quick look at today's agenda. We'll begin by exploring two primary ways to use ChatGPT, the web interface and the OpenAI API. Then, since many of you may not have a programming background, we will do a brief crash course on Python essentials. This quick Python introduction will help you feel confident about coding in the context of LLM interactions. Next, we'll dive into the heart of today's workshop, tips for prompting. In this section, you'll get hands-on with the OpenAI API in Google Colab to try out different prompting techniques in real time. I will walk you through various prompting strategies to get the most accurate and helpful responses from the model. After that, I will introduce ChatGPT's latest Canvas feature, which provides an interactive space for both writing and coding. Next, we will explore how to create a customized ChatGPT using the GPTs platform. This feature allows you to configure a ChatGPT instance specifically for your needs, such as for specialized support or educational roles. Finally, we'll look at what lies beyond basic prompting with two advanced techniques: Retrieval-Augmented Generation, or RAG, and model fine-tuning. By the end of the workshop, you will have a solid toolkit for effective communication with large language models, whether you are using the web interface, the API, or exploring customization options. I'm excited to dive in. Let's get started. Let's start by discussing two major ways to interact with OpenAI's large language model, the ChatGPT web interface and the OpenAI API. The web interface, familiar to most of us, is straightforward. Simply type a prompt into the chat box and you will receive a response. This method is ideal for quick, one-time tasks. Another way to interact with OpenAI's large language model is through its API. API stands for Application Programming Interface, and it allows programs, like those written in Python, to send prompts and receive responses from the large language model. Here is a Python code snippet that sends a prompt: write a short story about a university professor who can read minds, to the language model and retrieves a response. By the way, both the ChatGPT web interface and the OpenAI API used the same underlying large language models. But why bother with the API? The web interface is easy and intuitive, so why program it? Let's explore a scenario to understand the value of using the API. Imagine you are a professor using the ChatGPT web interface to grade homework submitted by your students. First, you would download all the homework, then upload each student's homework to ChatGPT using a prompt like, grade this homework and provide detailed feedback. Here are some instructions. ChatGPT will generate the feedback quickly, but you still need to manually copy the feedback into an email and send it to each student. This process must be repeated for every student in your class. While the grading itself is automated, you still need to manually collect the homework, upload it to ChatGPT, and handle the feedback distribution, which can be quite tedious. This is the limitation of the web interface. It is built for individual and one-time tasks, not complex workflows or batch processing. So it's not ideal for a professor who needs greater automation. A more efficient solution would be to automate the entire process with Python. You could write a Python program that downloads all the homework, sends each one to the OpenAI API for feedback generation, organizes the responses in a table. Of course, Python repeats this for each student. And finally, emails the feedback directly to each student. This approach saves significant time and effort, making the process seamless and fully automated. Just a reminder, the API enables two programs, in this case, the Python program and OpenAI's large language model, to communicate directly without using the web interface. So, using the API provides greater flexibility and control compared to the web interface. You can integrate large language model capabilities into other applications like course management systems, email servers, calendar systems, automate repetitive tasks, and tailor the model's responses. For instance, the OpenAI API enables specialized workflows, batch processing, and connections to your own databases or systems. However, it does require some programming knowledge to set up. Today, I will introduce you to the basics of using the OpenAI API in Google Colab. Before diving into OpenAI API, let's take a brief detour into Python essentials. Don't worry, I'll keep this as simple and practical as possible. I will cover variables, function calls, API keys, JSON data, and import statements using Google Colab. The link is in the video description. So, let's go to Google Colab. What is Google Colab? Google Colab is a cloud-based platform that lets you run Python code directly in your browser without setup. It's beginner-friendly, collaborative, and powerful, ideal for machine learning, data analysis, and working with APIs. Make sure you are logged in with your Google account. Let's start with variables. In Python, variables are like little containers for storing information. For instance, to store the name of our workshop, we do this. Workshop name, this is the name of the variable, equals empowering faculty with AI. This Python statement assigns the string empowering faculty with AI to the variable named workshop_name. Please note, this equal symbol here is used to assign a value to a variable, not to test equality like in mathematics. We can also put a number in a variable, like in this case, we assign number 22 to a variable named attendees count. So in this example, we defined two variables, workshop name and attendees count. So let's print them out. And here we're invoking a function called print, and we're passing the two variables to this print function. To run the code in Colab, click this play button on the left side of the code cell or press Ctrl-Enter. The first time you run a cell, you may see a warning. Just click Run anyway. As you can see, the print function prints the content that we assigned to these two variables, empowering faculty with AI and 22. Okay. In Python, there is a very useful syntax called f-strings. F-strings allow us to easily embed variables within strings by placing an F before the quotation marks, like this. The placeholders workshop_name and attendees_count get replaced by the values that we assigned to these two variables, making it easy to create dynamic messages. So for example, if I run this cell, you will see that the workshop will be printed as is. This one is replaced by the content, which is empowering faculty with AI, has 22 attendees enrolled. So if I go here and change this one to 23. Now, every time you change the code, you need to rerun this cell. And here, if I rerun this again, as you can see, this is now 23. Next, let's talk about functions and function calls. Functions are like small commands that we use to perform specific tasks. You have already used one, print, which is a built-in function. It comes with the Python language. And this is the syntax of calling or invoking a function. Print, open and close parentheses, and you can pass some variable to this function. So let's run this. You can also define your own function using this syntax. Def space function name, this can be anything. In this case, this function is not taking any input variable. This is called a function body. This statement will be executed when the greet function gets called. So here is the syntax of calling this function. If we call this function, the function body will be executed. In this case, print, hello, welcome to the Empowering Faculty with AI workshop. Let's try it out. And also pay attention to the indentation here. That's part of the function syntax. In this case, it's 4 spaces. You already know what an API is. It allows 2 programs to communicate directly. To use an API, you need an API key, which acts like a password for authentication. In our case, we need a key to access OpenAI's API. Please note, treat an API key like a password. It should always be kept private and safe. In this example, I assigned a fake API key to a variable called API_key. The next important concept is JSON data. JSON stands for JavaScript Object Notation. It is a format for structuring data, often used when working with APIs. Here is an example of a JSON object. As you can see, it contains 5 key-value pairs. The first key is name, and this is the corresponding value. Second key, second value, third key, third value, and so on. JSON is very popular because it is easy for humans to read and also for machines to parse. The last important concept I want to show you is imports. These are Python's way of allowing us to use external code that others have written. You don't want to reinvent the wheel. It helps simplify a lot of tasks, so we don't have to write everything from scratch. For example, here, we're importing OpenAI's library so that we can use its API. Think of libraries as toolkits that add extra functions to Python without needing to write them from scratch. All right, that's a super quick crash course on Python. Let's go back to the slides. Now that we understand the basics of Python, let's look at some tips for effective prompting. Communicating effectively with large language models involves using the right prompts in the right way. Here are a few prompting techniques that I found especially useful in my own work. Role-playing prompting, using delimiters, formatting the output, providing examples, chain of thought prompting, multitask prompting, and iterative prompt refinement. To make the workshop more engaging and relatable, I choose examples for each prompting tip tailored to academic and teaching contexts across the diverse departments of our attendees here. Let's go to Google Colab. To use the OpenAI API in Google Colab, follow these steps. First, let's install OpenAI library by running this code cell. Next, we need to set the API key. Without an API key, our Python program cannot interact with the OpenAI API. In this workshop, we have provided some code that loads the OpenAI API key for you. So you do not need to worry about purchasing an API key from OpenAI. If you would like to acquire your own API key for your own project, check out the link in the video description for a step-by-step guide. Once you get your own API key, you can replace my key with your own API key. Okay, so let me run this. In this code cell, I provided a helper function. The name of the function is getResponse. It takes two variables as inputs, prompt and a model. As you can see here, the model is hard-coded to GPT-4o. Throughout this workshop, we'll use OpenAI's GPT-4o model, but feel free to change this one to a model you like. Here is the function body. When this function gets called, this function body will be executed line by line. The heart of this function is this one here, which is also a function call. And this function call is the OpenAI API. As you can see, we're passing the model, in this case GPT-4o. We're also passing the messages with our prompt to this API. Once OpenAI's large language model generates a response, this API call will assign the response to this response variable. And the last statement in this function will return it to us. Don't worry about the details of this function. You just need to know that this function helps us pass the prompt to the OpenAI API and return the generated response to us. Throughout this workshop, we set temperature to 0. So what is this? The temperature variable controls the randomness and the creativity of the generated response. With lower temperatures, like 0 or 0.1, outputs become more conservative, coherent, and less diverse. And this is helpful for tasks needing accuracy. With higher temperatures, like 0.8, 0.9, responses are more creative, but can become less coherent, making it suitable for applications where variety or brainstorming is desired. In this case, I will set it to 0, so we can get more deterministic answer. Okay, so let's run this cell. Let's talk about tip 1, role-playing prompting. Role-playing prompting asks the large language model to respond as if it were a specific type of expert or professional. So, in the first example, before we let the large language model carry out a task like describe the key social and political changes in China during the early 20th century, we first ask the model to assume a particular role or persona, like you are a historian specializing in modern Chinese history. This will help create more targeted responses that align with specific fields or viewpoints. So this is the prompt. We save the prompt in a variable called prompt, and we pass this variable to our helper function, getResponse. And we're using GPT-4 model, and this function will return us the response. And we save the response into a variable called response and use the print function to print the response. Let's take a look. And it will take a while for the large language model to generate a response. Okay, so here we're getting the response, not in a web interface, but in Google Colab. As you can see, this is pretty good content. Here is a different example. Imagine you are a retail analyst specializing in fashion trends. Explain how social media influences consumer behavior in fashion merchandising. We pass this prompt to our helper function, we get a response, and we print the response. All right, very good. Next, let's move on to tip 2, using delimiters. It is recommended to add symbols to help the large language model distinguish instructions from the content the large language model should focus on. This makes complex prompts clearer. Delimiters can be anything like triple backticks, triple quotes, angle brackets, tags like this, or simply just colon. Let me first show you an example without using delimiter. And you can see that in this case, the large language model may confuse the content with the instructions. So here is the prompt. Edit this. Make an academic advisor for undergraduate computer science students at TCU who provide support on course selection, degree planning, important program requirements, and so on. Then we have an empty line, and I'm going to upload a document with detailed advising information which should be referenced in your response. So let's run this. Look at this part. In this example, the language model struggles to understand where my instruction edit this ends. Does it end here or here? Apparently, it thinks the second sentence, I'm going to upload a document with blah, as an instruction, not part of the content to be edited, since it is asking me to upload the document with detailed advising information. But it is really part of the text I want the large language model to edit. So how to fix this? Simple. Use delimiters around the text or the content you want a large language model to analyze or edit. So in this case, I'm using triple backticks as the delimiters. Let's run this again. And now, large language model can distinguish the instruction from the content. It will no longer treat the second statement as an instruction. Let's look at other examples. In this example, we first assign this string into a variable called theory. Attachment theory suggests that early relationships with caregivers shape a person's approach to future relationships. And here is how we construct the prompt. We're using fstring, analyze the text delimited by triple backticks, focus on the main psychological implications. As you can see here is a placeholder which will be replaced by the content in this variable. And we pass this variable prompt to get response, and this one will return the response. So let's run this. And we got good result. In the last example of tip 2, we're asking ChatGPT to find the problem of a given Python program. So here is the program. We assign it to a variable called program. And here is the prompt. In the prompt, first we give instructions. I have the following program that calculates the factorial of a number, but it's not working correctly. Please help identify and fix any errors, and so on. Here is the program. I'm using delimiters around the program here, because after this content, we also have more instructions. So as you can see in this example, there are instructions before and after the content we want ChatGPT to analyze. So it is very necessary to use delimiters, such as triple backticks in this case, to make your prompt clearer. And let's run this. Okay, as you can see, it finds the problem. The issue is with the conditional statement. In Python, equal sign is used for assignment, not for comparison. For comparison, you should use equal equal. This should be an equal equal one. All right. Tip 3, formatting the output. We can ask the large language model to present its response in a specific format, such as bullet points, lists, tables, numbered steps, Markdown, JSON, or HTML to enhance clarity and readability. Let's look at the first example. So here is the course information of Introduction to Environmental Science. This course is taught by Dr. Jane Doe, and this is her email. And this is the purpose of the course. Key readings include the weekly schedule, first week, second week, and so on. Okay. And here is the prompt. As you can see, here we're using tip 2, the delimiters. Given the course info text delimited by triple backticks, extract the information from the text above and format it as a simple HTML syllabus page that could be embedded on a university website. The university's color is white, only output the HTML code. All right. So after passing the prompt to our helper function, we get a response, and let's print it out. If everything is fine, response will contain the HTML code with the information extracted from the course info. All right. So here we have the HTML code. It looks okay, I guess. So let's render this HTML inside Google Colab before we post it on the university's website. So here is the syntax. Again, don't worry about the details. Just run the code. All right. This is an okay website for me. ChatGPT extracts the name of the course, the instructor's information, the course description, key readings, and the weekly schedule, and put them in a very nice HTML web page. Let's look at the second example. Here is some text. A recent study on social behavior led by Dr. Thompson at the University of Behavioral Sciences looked into the effects of group size on individual decision making. And here we have some findings, and this is the sample size, the age range, and the p-value, also future research. Okay. And this is our prompt. Given the text, extract the relevant details from the text above and format them as a JSON object. And this JSON object must include the study title, researcher name, institution, study focus, key findings, sample size, age range, significance level, and future research directions. So we're explicitly asking for a JSON output. Okay, so let's run this and see what happens. As you can see, ChatGPT generates the output that we like. Next, tip 4, providing examples. We can give examples within the prompt to guide the large language model on the type of response or format desired. This will help achieve consistent and relevant outputs. Let's look at the first example. So here in the prompt, we're asking ChatGPT to provide an overview of nutrients and their benefits using this format. We gave 2 examples, vitamin C and calcium. And for each nutrient, we would like to know 3 perspectives of this nutrient: function, sources, and benefits. So let's look at the last sentence, this instruction. Now, describe the following nutrients in the same format: iron, fiber, and omega-3 fatty acids. And let's see the response. Okay, great. As you can see, ChatGPT is following our instruction and generating the output we like. In this example, we ask ChatGPT to answer questions from my students. And here are some example Q&A. What's the difference between a comet and an asteroid? And here's the answer. Great question. Space rocks with personality. And so on. Why do cats purr? Ah, the mysterious purr. Cats purr for a variety of reasons, and so on. So as you can see, each answer is very encouraging, clear, and also humorous. In the end, if I ask, what's the speed of light? And we ask ChatGPT to generate the answer. ChatGPT will pick up the warm and friendly tone from those examples and generate an encouraging, clear, and humorous answer. Let's see. The speed of light is like the universe's ultimate speed limit. In a vacuum, light zips along at about this kilometers per second. Imagine it as the fastest courier service in the cosmos, delivering light from the sun to Earth in just about 8 minutes. So next time you flip a light switch, remember that those photons are racing around at breakneck speed to brighten your day. This is a very warm, friendly, and humorous answer. So by providing examples with a consistent structure, tone, or type of content, you set clear expectations for the large language model. This ensures the responses are aligned with the format you need. Tip 5. Chain of thought prompting. If the task is a little complex, it is a good idea to request the large language model to think through steps or stages rather than jumping directly to an answer. This will improve logical reasoning and makes complex answers more transparent and structured. In this example, we're asking ChatGPT to solve a math word problem. A farmer has cows and chickens. Together, they have a total of 30 heads and 100 legs. So, how many cows and chickens are there? In chain of thought prompting, it is very important to add this very last instruction. Let's think step by step. So explicitly asking the model to take things one step at a time often yields the most reliable outcomes. I encourage you to use phrases like, let's think step by step, or let's break down this problem. This will help guide the model. Let's see the result. The response is in Markdown syntax. So let me copy the output and let me create a text cell. Let me paste it here. Google Colab's text cell can parse the Markdown syntax and render it into a human-readable format. And Control Enter. All right, so this is much better. To solve this problem, we can use a system equations like this. We know two things from the problem. 30 heads, 100 legs. So we can have these two equations. Now we have a system of two equations. We can solve this using substitution or elimination. And here is the detailed math. Therefore, the farmer has 20 cows and 10 chickens. I think chain of thought prompting makes a lot of sense. Consider our own thought process when solving a complicated reasoning task, such as a multi-step math word problem like this. It is very typical to first decompose the problem into intermediate steps and then solve each before giving the final answer. So be nice to a large language model, and you can ask it to think step by step. This is a very effective prompting technique. Next is our tip 6, multitask prompting. We can ask the large language model to handle multiple tasks in a single prompt. In this example, the text describes the recent climate conference. And here is the prompt. Analyze the following text delimited by triple backticks, right here, and perform the following tasks in sequence. Step 1, provide a brief summary. Step 2, translate the summary into Spanish. Step 3, assess the sentiment of the original text as positive, neutral, or negative. And step 4, extract the main keywords. In this case, I also ask for this specific format. First, show the original text, then the summary, the translation, sentiment, and keywords. And here is the given text. All right, so let's see what happens. All right, so here is the output we like. This is the original text, a short summary, translation into Spanish, sentiment is neutral, and here are the keywords. All right, last but not least, tip 7, iterative prompt refinement. It is very hard to get the perfect prompt at the outset. So naturally, we should adjust the prompt based on the initial response to get a more focused or detailed answer. Here is the example. Let's start with a simple prompt asking for a description of different teaching methods. So this first prompt is very basic. We got this long list. As you can see, the initial response is a brief list of teaching methods without any detail. Let's refine this prompt to get a more comprehensive answer. So this is our refinement 1. Describe different teaching methods, including lecture, discussion, and demonstration. So we're only interested in the first 3. And explain how each method is applied in a classroom setting. So now we have more information on each method and how they work in the classroom. We can keep improving this further by adding information about, for example, the strengths and limitations of each method. So describe the different teaching methods, lectures, discussions, and demonstration for each method. Explain how it is applied in a classroom setting, along with its strengths and limitations. And this is refinement number 2. All right, so we have strength limitations, strength limitations, strength limitations. And once again, those weird syntax are markdown syntax. You can copy this and paste it into a text cell, then run the text cell to see the styles. Now, in the third refinement, let's add considerations for different learning styles. So this is the same here, and how it supports different learning styles. Okay. So in conclusion, through this process, we refined the prompt step by step, each time expanding the depth of information. Iterative prompt refinement is a powerful way to guide a model towards delivering increasingly detailed, structured, and insightful responses. This approach can be applied across many fields to build complex and rich content. That's all for tips for prompting. Let's go back to the slides. Next, I'd like to introduce you to ChatGPT Canvas, an exciting new interface that enhances how we can write and code collaboratively within ChatGPT. What is Canvas? Canvas is a dynamic visual workspace where you can interact with your content in a hands-on way. Think of it as a more advanced interactive version of Microsoft Word, designed to support complex writing and coding projects. It makes it much easier to refine ideas and get precise feedback from ChatGPT in real time. I will show you some examples in a moment. Let me briefly highlight a few key features, which you will also see in my demo. Inline editing and feedback, customizable tools, so you can easily adjust length, tone, reading levels, and more. Version control lets you track and restore previous versions of your work. In short, ChatGPT Canvas combines the strength of ChatGPT with a more interactive, flexible workspace, opening up new possibilities for creative and technical work alike. All right, enough theory. Let's try it out. First, let's select GPT-4o with Canvas from the dropdown. Here in the chat box, I'm going to paste in a prompt to demonstrate how it works. I'm an associate professor in computer science organizing a workshop series called Empowering Faculty with AI for Scholarship and Teaching. Most attendees are professors with little programming experience. I'm planning 5 workshops covering topics like here. Now I'm preparing workshop 2, Effective Communication with LLMs. I want this session to be hands-on and interactive, lasting less than 1 hour. To make sure ChatGPT is using Canvas, I always explicitly tell ChatGPT to use Canvas. Please help design this workshop using ChatGPT with Canvas. Let's send it and see what happens. Wow, this is a completely different experience from regular ChatGPT. Instead of just a single chat window, the screen is split into 2 parts. On the right side, we have an editor displaying the generated workshop outline. And on the left, we can continue chatting with ChatGPT to make changes to this generated workshop outline. And this is a pretty good outline. Workshop 2, duration, objectives. Here is the agenda. 5 minutes for introduction, 10 minutes for prompt design, 10 minutes for interactive demo, 20 minutes for breakout activity, hands-on prompt practice, 10 minutes for group sharing and discussion, 5 minutes for wrap-up, and 5 minutes for Q&A. Okay, now let me show you some features of Canvas. First, we can directly edit this generated outline. So let's select this title. As you can see, a pop-up appears, allowing me to format this title. So let's change it to heading 1. Okay. So this feels a lot like working in Microsoft Word, right? I can also ask ChatGPT to make edits directly. For example, here I can click this plus and ask ChatGPT to add an introduction to the workshop organizers, John, Tom, and Tim, in this section. Did you see that? ChatGPT Canvas edited just this section. Other sections remain the same. And let's say we want to get rid of section 7. So we can ask ChatGPT to remove section 7 Q&A, and next steps. And here we can manually delete this one as well. On the left, you can see the corresponding prompt it is using to make those edits. Unlike regular ChatGPT, Canvas only updates the selected part of the document, rather than regenerating the whole thing. This makes for a smoother, more efficient editing experience. So let's try more edits. Let me select this and ask Canvas to change the length of the workshop to 2 hours and update the entire outline. Wow, look at this animation here. So this time it is changing the entire document. Of course, because we extend the workshop to 2 hours, right? But I just changed my mind. I don't want it to be 2 hours. So let me introduce this undo feature right here. So we can go back to the previous version. I can quickly restore the previous version and keep it to 1 hour. 2 hours would be an overkill. So here, for example, we can ask Canvas to create 2 more tasks. So it added these 2 new tasks, but here it has some duplicates. So this feature is still a little buggy right now, but it is pretty impressive. You can also ask ChatGPT Canvas to explain for you. For example, let's assume that I do not know what is FAQ. So here I can select FAQ and ask, what is FAQ? And you can see that on the left, ChatGPT provides a quick explanation without really changing my content. Next, let me direct your attention to the lower right corner here. There are many tools you can use. Suggest edits, adjust the length. So for example, here is the current length. If you think the current outline is too long, you can make it shorter or shortest. So once you select the shortest, you can click and confirm. As you can see, a very short outline is generated. And let's go back. You can also adjust the reading level. So this is the current reading level. And you can drag and drop it to high school, college, grad school, or here is middle school, kindergarten. So let's try kindergarten. I'm not sure if this is understandable by kids from kindergarten, but it is a nice try. Let's go back. All right, so here is add emojis. Let's see the result. All right, that's very cool, right? And ChatGPT adds a lot of emojis here. Okay, so let's go back. Canvas also has a add final polish. So if I click add final polish, which applies a comprehensive review to smooth out any language inconsistencies or improve flow, perfect for making sure everything sounds polished before presenting or publishing. Finally, let me demo this suggest edits feature. So for example, let me add some grammatical errors. Here, let me delete 2. And here, maybe add hand-on experience, developing. Okay, then click Suggest Edits. Okay, very cool. As you can see, Canvas quickly identifies the errors and suggests several fixes. Much like Microsoft Word's review tool, but this time it is not human reviewing your document. ChatGPT is helping make suggestions. So here I can click Apply. And here, Apply. And here, it finds this inconsistency and changing developing back to develop. Very impressive. Okay, next, I want to show you how to use ChatGPT Canvas to write Python code. And of course, you can write code in another programming language. So let me go back and start a new chat. Here is the prompt. I'm asking ChatGPT Canvas to write Python code for a simple number guessing game where the player has to guess a number between 1 and 100, give feedback if the guess is too high or too low, and limit the player to a maximum of 10 guesses. I need to run this program in Google Colab. Use ChatGPT with Canvas. Here we go. All right. So the program is ready. And let me copy this and paste into Colab. So we're back in this Google Colab. And let's scroll down and add a code cell and paste. So this is the code, import random, and this is the definition of number guessing game. And here is how we invoke this function. So let's run it. All right. And the game starts. So let me put 50 there. Too low, try again. 75. Too low. Then 87. Still too low. Let's put 93. Oh, this time is too high. And then let's try 90. It's too low. So I'm almost there. 91. Congratulations, you guessed the number 91 correctly in 6 attempts. All right, very good. Let's go back to ChatGPT Canvas. And here I want to show you something. I will add a small bug in this program on purpose. Recall that in Python, equal means assignment, and equal means equality. So here it is checking if the user's guess is equal to the correct number, the number to guess. If so, print congratulations. Else, if it's less than the number to guess, print too low, otherwise print too high. Let me change this equality test equal to equal. So here we're not doing equality test, but we're assigning this number to the user's guess, which is absurd. This is a very common beginner's mistake. And of course, if you run this program, it will not function well. So I want ChatGPT to help me remove the bug or debug. And of course, you can ask ChatGPT, this program does not work, help me debug. Or you can click here and click this fix bugs. So select, click, and pay attention to line 26. Look at this nice animation here. Here it says, I fixed the bug in the code where the comparison operator was incorrectly used. And this is very impressive, and I really like that animation. And there are other tools. For example, you can do a code review, which basically means ChatGPT will review your code and tell you how to improve your code and to make it more elegant and high quality. And here is, you can convert this Python code to a different language, like PHP, C++, JavaScript, TypeScript, or Java. So let's convert this to Java. As you can see, this is the same game in Java. And let's convert it back. Okay, when we convert it back, we lose all the comments. Now remember, we write code not only for machines, but also for human beings to read. So it's a good idea to add comments to this program. All right, as you can see, ChatGPT Canvas is adding those comments for this program, making it much easier to understand by human programmers. You can also add logs, but I'm not going to demo that to you. A quick summary. ChatGPT Canvas offers a new way to interact with ChatGPT for creating, revising, and refining complex content, making it a fantastic tool for anyone looking to boost their productivity and creativity in writing and coding tasks. Let's go back to the slides. Our next topic is building a custom ChatGPT. Since the launch of ChatGPT, many people have asked for ways to tailor it to fit their specific needs. Let me introduce GPTs, custom versions of ChatGPT designed to act as specialized assistants for unique tasks. Rather than a one-size-fits-all chatbot, GPTs allow us to create versions of ChatGPT that are truly customized to our needs. The best part? No coding experience is required to build a GPT. You can set one up in 3 simple steps. Step 1. Provide instructions. Step 2. Add knowledge. Step 3. Define capabilities. Once we are satisfied with our custom GPT, we have 2 options for sharing it. We can either publish it in the GPT store so that others can benefit, or keep it private for personal or team use. So now, let me walk through an example of creating a custom ChatGPT specifically designed to help advise computer science undergraduate students at TCU. Let's click Explore GPTs. And here you can find different custom versions of ChatGPT created by other people. And they are grouped in different categories, like writing, productivity, research, education, lifestyle, programming, and so on. Think of this as OpenAI's App Store. Let's create our own. In this example, I want to create an academic advisor to help advise computer science undergraduate students. So here I'm going to write, make an academic advisor for undergraduate computer science students at TCU who provides support on course selection, degree planning, important program requirements, and so on. So first, it gives a name to this GPT. It's called TCU CS Advisor. Well, that's pretty good. Next, ChatGPT will create a profile picture for this GPT. Okay, that looks good. Next, I'm providing a document with detailed advising information, which should be referenced in your response. And let me select my personal advising cheat sheet. As you can see, it is updating the GPT. So what would you like to refine next? Let me upload more knowledge. I'm providing the computer science programs for your plans and course prerequisite information, which should be referenced in your response. And let me select these two PDFs. I also recommend you add this instruction. If you don't know the answer, please direct the student to contact their academic advisor for assistance. Now I can share this GPT with my students, and they can ask questions to this GPT. For example, can I take linear algebra elsewhere and transfer it to TCU? You know, based on the academic advising Word document, we discourage students from taking linear algebra elsewhere. So let's see the result. Okay, as you can see here, we recommend students take both linear algebra and discrete math at TCU. This is because blah, blah, blah. This is very good. Okay, so let's ask a question about the 4-year plan. I am a junior CS student at TCU. What CS classes should I take in the fall semester? Okay, as you can see, it provides very good answer, consistent with our 4-year plan. Next, let me ask an even tricky question. What is the prerequisite of analysis of algorithms? It is partially correct. It is not considering the discrete math too. So let me ask it again. What is the math prerequisite of analysis of algorithms? Now it is completely wrong. I think this may be caused by the PDF I sent. It is a picture, so the lines between the boxes are kind of ambiguous and not clear to ChatGPT. Now this can be easily fixed if I convert everything in the prerequisite graph to text. So if ChatGPT is not giving the answer you like, you may check the content in the PDF you uploaded. Next, let's look at configure. And here are the configurations generated by ChatGPT. Here is the name, and here is the description. And by the way, you can change them if you want. And here are the detailed instructions of this ChatGPT. This GPT serves as an academic advisor for undergraduate computer science students at TCU. Here is a role. The advisor references details from the academic advising document for your plan and prerequisite information. The advisor helps students navigate course offerings and so on. And feel free to change this instruction so you can change the behavior of this GPT. And here we have conversation starters, and you can also add or remove starters. This part is the uploaded knowledge base. We have 3 documents. So here are the default capabilities of this GPT. This GPT can do web search and can create images. Here is where you can delete this GPT. So once you are done, you can click this Create button to share your GPT. And here you have 3 options: keep it private, anyone with the link, or share it in the GPT store. So let me click Save. And let's click View GPT. Okay, so this is a custom ChatGPT for advising students. But remember, there is a small bug in the prerequisite information. And I'm sure that can be easily solved by replacing the pictures with text. And by the way, you can access your GPT on the left side of this dashboard. So go ahead and create your own GPT. And let me know what GPT you created by leaving a comment below. Let's go back to the slides. Finally, let's briefly discuss some advanced concepts beyond prompting. Let's start with Retrieval-Augmented Generation, or RAG. So what problem does RAG solve? Recall that in Workshop 1, I mentioned that although ChatGPT has vast knowledge learned from the internet, it doesn't have access to your or your organization's private, unpublished information. For example, if you ask, "Can I transfer linear algebra to TCU?" ChatGPT interprets this as a general question and does not know specific departmental policies, like an unwritten rule discouraging taking linear algebra elsewhere. Consequently, it will provide a general answer rather than specific guidance tailored to your department's rules. Still from Workshop 1, to bridge this gap, I can upload my unpublished private academic advising document to ChatGPT and then ask questions about it directly. You saw that in our TCU CS Advisor GPT as well. It turns out that behind the scenes, ChatGPT is using a technique called Retrieval-Augmented Generation, or RAG, to accommodate this additional new knowledge source. Let's take a look at how it works. After uploading the academic advising Word document to ChatGPT, it will first split this lengthy document into chunks. Each chunk will contain several paragraphs focused on specific topics within the document. For example, one chunk might include details on searching for classes or finding course information. These chunks are then stored in a database. Now, when the user asks a question like, "I want to take linear algebra at a university in my hometown this summer. Can I transfer it to TCU?" Instead of answering directly, ChatGPT will search the database to identify the chunk most relevant to this question. Since transferring linear algebra to TCU relates to transfer credit policy, ideally, ChatGPT will select the relevant chunk containing that information. The third step is to create an updated prompt by including the retrieved text. Use the following pieces of retrieved context to answer the question. If you don't know the answer, Just say that you don't know. Use 3 sentences maximum and keep the answer concise. This instruction is followed by the retrieved context and the original question. This results in a longer prompt because it provides essential context to the model along with the question. Recall from our first workshop the limitations of prompt input length for large language models. So this is really the motivation behind RAG. Instead of including an entire long document, RAG selectively pulls only the most relevant information. For example, there is really no need to include information about how to get a minor when answering a question about transfer credits, right? So this process, known as Retrieval-Augmented Generation or RAG, allows us to generate a response by augmenting the model's prompt with only the necessary retrieved information from a very long document. Once this prompt is constructed, the final step is to feed it to the model, enabling the model to generate a clear, relevant answer regarding the transfer of linear algebra credits. In summary, RAG is a technique for enhancing a model's knowledge with specific additional data. While large language models have broad knowledge, their information is limited to data available up until their training cutoff. Or they may have never seen your data because it is private or unpublished. RAG allows us to build AI applications that can incorporate newer or private information into the model's responses. In the end, let's talk about model fine-tuning. As you already know, a large language model can be considered as a very knowledgeable generalist. However, we may want them to become a focused expert in a particular area, like teaching mathematics. That's where fine-tuning comes in. It allows us to take a generalist large language model and guide it to specialize in a specific subject, making it a more effective educational tool. Then how? Recall that a large language model gets its power from a vast number of learned parameters, say 175 billion, trained on data from across the internet. To turn it into a mathematics-focused educational assistant, we need to provide it with additional specialized training data, such as math curriculum and lesson content specific to your organization, examples of past student questions to anticipate common challenges, feedback and grading rubrics to provide constructive guidance, and maybe personalized learning goals to support students on their unique learning path. Please note, the original large language model has never seen this data before, as it's private and unique to your organization. Remember the analogy? Think of a large language model as a recent college grad. Fine-tuning is like the college grad goes to grad school and keep learning. When fine-tuning the model, we are careful to preserve what it already knows. The large language model's billions of knowledge parameters are like a vast web of interconnected understanding. Instead of retraining everything, we freeze or lock most of these parameters to retain the model's general knowledge. We then adjust or tweak only a small portion of the parameters, less than 1%, sometimes even just 0.5%, so it can specialize in a new mathematical-focused content without losing its broader understanding. By fine-tuning the large language model with this targeted data, we make it more effective mathematics tutor, tailored to students' need. In summary, fine-tuning allows us to transform the large language model from a generalist into a specialist by introducing it to focused data like curriculum content, student feedback, and individualized goals. Freezing most of its parameters allows it to build expertise in a new area while still retaining its original knowledge, making it a highly effective tool for providing personalized student support. But I have to say, fine-tuning is a complex and a challenging process that requires a deep understanding of large language model architecture as well as advanced programming skills. To summarize today's session, we began by understanding two key ways of interacting with large language models: the web interface and APIs. APIs give us more control, allowing for a customized and scalable approach. We then covered Python essentials, giving you the basic skills to communicate with a large language model programmatically. Next, we explored prompting techniques like role-playing, using delimiters, examples, chain of thought prompting, and so on. These tools can help you get more accurate and relevant outputs. We also looked at features like ChatGPT Canvas for interactive experience and how to build custom versions of ChatGPT to fit specific needs. Lastly, we touched on advanced methods like Retrieval-Augmented Generation, or RAG, and model fine-tuning. They are helpful when the base model's capabilities need enhancement or when domain-specific knowledge is required. I hope you learned something from this workshop. See you in the next video.